Hello friends, how are you? Welcome to my workshop on professional structure engineering. Myself Satish Jethwani, I am from Easy Engineers Private Limited. Here in Easy Engineers Private Limited, apart from providing consultancy design services, we do offer practical professional training on structure engineering. Here we run the courses on RCC structures, steel structures, softwares and many more things apart from conceptual design training. Let's have an example. A simple example of a beam. Yes friends, which is this beam and which is this beam? Type A and type B. Okay, can you tell me what is this? Yes everybody? Yes, you are right. This is simply supported beam and this one, yes, fixed beam. Now this we have learned in our academic, in our bachelor's and in our diplomas. Okay. Now, how this beam will get deflected when a load is applied at the center? For example, this, when we apply the load, the deflection will be something like this, and in this case, the deflection will be like this. Now, my question is, have you ever tried this, or you have just read from the book that for simply supported the deflection will be like this and for fixed beam the deflection will be like this? Have you ever tried? See, understand friends, all the times we don't need big laboratories and expensive material to try all these things. We can do this simple thing with even a simple scale. Would you like to see how? Let's see. May I call some from you please? See, here now we are applying load on this scale. Okay, can you apply with the finger please? See friends, this is a deflection curve of a simply supported beam. Now let's see for a fixed beam. Yes, slightly more. See, can you see the shape? Okay, let's make this shape more clear with the soft one. Okay, now please, this is simply supported and now this one is fixed. See, can you see this shape? Exactly like this? Yes, thank you. Now after looking at this shape, now can you tell me the picture what I am going to show you, which beam is that, whether it is a simply supported or a fixed beam? Please have a look on this. Okay friends, now, yeah, tell me. Everybody please. Yes. Can anybody tell me? Okay. Confusion? Whether it's a simply supported or fixed? See, now this is the problem. This we have covered in our academic, but the picture which I showed you, this is not covered in academic. This practical thing now I will explain you friends. This is column, this is beam. Okay. Now when this beam is getting deflected, for example, I draw the double line of this goes something like this, and in this case, this goes like this. Everybody clear? So, let's see. Focus on this space. What happens? In simply supported, this face gets rotated. There is some theta. Whereas in the fixed one, this is not getting rotated, the theta is 0. Okay. Now how can we achieve this? Let's see. For example, this is an I section beam friends, and I am holding it from here. Okay. And let's see whether it gets rotated. Yes, of course it is getting rotated. I mean this face gets rotated like this. Okay. Say instead of one bolt I provide 2 bolts. Okay. Yes, it still gets rotated. Slightly lesser, but still gets rotated. Now quite less, but still this face gets rotated. Okay. Now how can we make it fixed? Let's do some magic. Okay, see the magic. It's not rotated now. It's not rotated. What we did? Yes, anybody? Simple thing. When we hold from the center, it gets rotated. But when we hold from top and bottom, it's not getting rotated. That is the simple logic. Now, if I see any connection, my dear friends, in this, if I provide a cleat angle with bolts in between, okay, this can rotate because there is some space here, right? Now, many of the engineers think like that when we are providing weld, it is fixed. No, it has nothing to do with it. Even if you weld it here, this is simply supported only. See, whether we bolt or provide weld, it doesn't have any difference on simply supported or fixed. But where you are providing weld, where you are providing bolt, it has to take concern with this. Understand? If I provide bolt or weld, this beam can rotate. But if I provide a beam like this and say there is no space for rotation here, can you see this space, friend? Okay, I will see. I am talking about this space. I am talking about this space. If there is a space, this can rotate. So that will be simply supported. But if there is no space or the space is filled with weld, okay, one option no space, another option you fill that space with the weld, or third option you provide the plates. In all these three cases, the connection will become fixed. Let's have again a look on this structure, on the beam which we show. Yes, can you see the space there at top and bottom? Yes. So now, which is this connection, everybody? Yes, you are right. It is simply supported beam. Now let's see one more picture. Yes, can you see this? We can clearly see the weld is provided near the flanges. So there is no space at top and bottom. That means this connection is fixed connection. Everybody clear about this? Though there is a space near the web, but there is no space near the flanges. That's why this connection is fixed. Now you see any connection, whether at railway station, at bridges, at sheds, factories, and you can quickly identify which is this connection. Am I right, dear friends? Okay. Now, which this connection simply supported, actually in industrial language we call this simply supported as shear connection. Okay, and this one we call moment connection, because this can transfer moment also, whether this transfers shear only. And understand friends, this moment connection also transfers shear, but this connection transfers shear only. Hello friends, now we have seen the connection types. Okay, now you can easily identify the connection type by merely looking at that. Okay, now similarly let us understand how we can identify the support, whether it is pinned or it is fixed. Let's have a look. Say this is a steel column, these are the flanges, okay. This is base plate and below it, of course, it's a RCC pedestal. Okay. Now, here we will discuss about two types, pinned as well as fixed. Now, similar to shear connection and moment connection, if we hold this column from center, this will behave like pinned, and if we hold it from ends, it will be fixed. So, let us say this can get rotate like this. So friends, when I put anchor bolts like this, so of course this plate cannot rotate like this and it will be fixed. That means if I draw plan of this, then the plan will be something like this. This is fixed column. Okay. Now can anybody tell me, if I want to make this column pinned, what should I do? Yes, anybody? Okay. If I remove the anchor bolts, then this column will fall down. Of course, we don't want to get it fall down. We want to make this column pinned. So what can we do? See, this is a base plate and this is a column. This column is welded with base plate and this assembly comes at the side along with this, like, okay, this full assembly comes at the side. And now I put this on the pedestal and then anchor bolts are put on the pedestal. So by putting this anchor bolts in between means like this. Say this is a column, okay. Then we are putting anchor bolts in between. So this will be now pin support. Understand friends? By putting this here, we allow just few rotation. We are allowing just fraction of radians. Okay, we don't want to make it seesaw. So if you see the anchor bolts are inside, it will be called pinned, and if the anchor bolts are outside, it will be like a fix. I will explain you with a model. See dear friends, this is a base plate, this is column, okay, can you see this? That means this is pin support and this one is, my dear friends, fixed supports. Okay dear friends, so I guess now you know which is pinned and which is fixed. Now it's not merely on paper only, now you literally know and you can identify easily when, for example, you are taking some selfie and in selfie you can see some support. So even in selfie also you are able to identify, isn't it? Am I right?
This is how you learn structural engineering. And this is how we learn structural engineering at EZ. Here, practical applications are given equal value as the number crunching is. The experts who train you here are not only from academic background and won't just be reading out books to you, but they have vast experience through diversified projects and will provide you exposure of actual structure design procedures from the live projects they are working on. EZ has participants from all over India and abroad, which includes not only students but also university professors, government executives and even MNC employees. EZ has conducted training programs for leading multinational companies and universities as well, and holds the highest number of job placements compared to most major institutes you know of. And of course, EZ trainers are more than qualified to do so, making learning at EZ easier. Did you know EZ has courses that no other institutes in India have? Courses like STAAD Pro with advanced structure concepts, advanced steel structures, advanced concrete structures, and more. Lastly, EZ is also the highest rated institute on social media. So, what are you waiting for? Contact us and be ready to change the way you learn.
Okay friends, now you are able to identify moment connection, you are able to identify shear connection by merely looking at that. Now what do you think? this same types of connection, will it be available in RCC also? I mean to say, in RCC, can we make the beam fixed or can we make it pinned also? Yes? Only fixed? No. In RCC also, we can make a pin connection. Okay? Let's see how the connection type is decided. This is beam and column frame. Okay. Now similar to steel, again, if I hold from center, it is simply supported. If I hold from top and bottom, it is fixed because this is not getting rotated. So here also, if this face is allowed to rotate slightly, we are not going to make seesaw, of course. It's just fraction of radians. Okay. So if we allow this, then it is simply supported. Now how can we allow this? Understand. If we provide reinforcement like this, and if we can pull this point, if we can pull this point A up to A dash, then it is simply supported. Now, what will happen? Say there is a load, of course there is a moment, so this will create a pull. Now this reinforcement is in pull, there is a pull like this. Okay. Now how we can control this? I will give a simple example. Say for example, dear friends, if I hold it like this, okay, can anybody can come please? Okay, I am holding like this, and can you please pull it? He is able to pull this. Now if I hold it like this and I tell him to pull, see, he is not able to pull. Okay, thank you. What is the difference? In the previous case, I hold it like this, okay, with a small gripping length, and in the next case, I increase the gripping length. So if I increase the gripping length, this will not allow pulling. This will not allow shifting of the point. So dear friends, that means if you put this reinforcement inside by enough length so that it cannot pull, that enough length means, yes, development length. If you put this reinforcement inside the column by the length equal to development length, this beam will be called fixed beam. But if you put less than that, how much? The practical value for that is LD by 3. So if you put LD by 3, then it will be pinned. For example, the reinforcement is say 12 mm diameter. Development length is generally 50 times diameter. Actually, we need to find accurately with the formulation, but generally the value is 50 times diameter of the reinforcement. So if it is 12 mm diameter reinforcement, means 12 into 50 equal to 600 mm. So if this reinforcement of 12 mm diameter is extended in the column by 600 mm, then it is fixed. But if I put LD by 3 means 600 by 3 means 200 mm. So if I extend this reinforcement inside the column by only 200 mm, then it will be pinned. Now understand the criticality of this point, my dear friends. Suppose, for example, you have considered this as LD by 3 pinned in software. That means you have released the moment in STAAD or in any other structure analysis and design software. But at the site, while placing the reinforcement, that person has put the reinforcement with a length LD extending in the column. So what will happen? You designed like this but executed like this. Okay, so what will happen? In simply supported there is zero moment at the end, while in fixed beam there is moment, in fact maximum moment at the end. So this moment will now transfer to the column for which it is not designed. That means column will fail. Understand friends, even a single element failure can cause, just have a look what can happen if a single element of structure gets failed. Have a look please. So friends, this is very important. Understand, no software can teach you where to provide pin, where to provide fix. That is a separate learning, it's a concept learning. Okay friends, softwares in structural engineering. What do you think? How much they are useful? Of course they are useful, but how much? Yes, the work which you generally take maybe 4 months without a software, that same work you can do with the software maybe within 4 days only, and that also with higher accuracy. But if you have knowledge of software and you don't have knowledge of concepts, then softwares are of no use. Understand friends, in structural engineering there is no software which can decide the location of bracing. There is no software in the world which can decide the location of moment connection. There is no software in the world which can decide the column orientation. This you need to give input to the software. Remaining work will be done by software. So many times it happens that we are only stick to software, we learn software and then we say we couldn't be structural engineer. Why? Because you have done softwares but you have not learned concepts. Okay, before going into the depth of all these concepts in structural engineering, let's first see which are the softwares used in civil engineering field. Okay, yes, let's list out category wise. AutoCAD, MicroStation, ZWCAD, STAAD, E-Tapes, SAFE non-linear, SAFE, and many more. These are the softwares for analysis and design purpose. Okay? And these are the softwares for drafting purpose. Okay? Yes, any other work? Yes, 3D modeling softwares. Revit, then Civil 3D, then there is 3D Max, AutoCAD 3D. These are 3D modeling softwares. Okay. In Revit, we have Revit structure and Revit architectural. Again, Revit structure is not for analysis and design. Revit structure is for modeling the structural elements. But finally, these all softwares are for 3D modeling only. Now, let's see what is the minimum qualification required to learn this software. For drafting software, you need diploma or ITI or any equivalent course. Okay. For analysis and design purpose, for all these softwares, you need BE or ME or any equivalent degree. Again, for 3D softwares, you need diploma or even ITI. In this analysis and design softwares, you need BE or ME in civil engineering or structure engineering. Whereas here, you can do diploma in any of the stream, maybe in mechanical, electrical, and still you can use all these softwares. Now, but looking at the present scenario, you know, my dear friends, unfortunately, more than 90% of BE or ME civil engineers are actually working on this. They are either in drafting or they are having a job profile of 3D modeling. Why? Why? The reason is simple, because they thought if we learn this software, we will be structure engineer. But it is not the case. Merely by learning this software, you cannot be structure engineer. To learn this software, first you need to clear your concepts. Before going to software, you need to learn concepts. What do you mean by the concepts? Say, for example, there is a structure. Okay? Now, you want to model this structure instead. Say, for example, you have already undergone the training of STAAD or ETAPS or both, or maybe even SAP. But in that training, you have learned how to model column, how to model beam, even in RCC or steel or any material. You have learned that. You have also learned how to model bracing. But have you learned in that software where to provide bracing? Have you? Of course not. Because it's not part of software learning, my dear friends. So if you don't know where to provide this, if you don't know where to provide this plan bracing, if you don't know which type of connection I need to model in the software, then is there any meaning of learning software? And exactly this happens. That 90% of engineers have learned this software, but they have not learned this thing. So this thing can be learned by actually working on the projects. If you are working for many years, say at least 4 or 5 years on the projects in structure design engineering, then only you can learn this. But fortunately, we have one more option to learn these things, and that option is Easy Engineers Private Limited. Here in Easy Engineers Private Limited, we have a practical course of professional structure engineering. This course is about 4 months course. In this 4 months course, we teach you steel structural analysis and design, concepts, softwares, RCC structural analysis and design, what are the types of documents which we need to prepare for the projects, what are the types of drawings, how to study them, how to get input from architect, what inputs will be available, what inputs we need to take from mechanical engineers, what inputs we need to take from electrical engineers, and what output we need to give to the site person. All these things along with connection design, crane girder design, monorail design, rebar detailing, and so many things. All these things which you will otherwise be learning when you will be actually working for so many years in the projects, that we will teach you here. And if we are not able to teach you, if you are not able to understand all these things, then your trainings are free. Simple. Okay? Even if you don't want to undergo for the full 4-month course, you have options for short courses. We have courses for even 10 days. We have courses for 20 days. And more, we have almost 4 to 5 courses where we cover all these things. For more details on this, you can log on to www.ezengineers.in or you can call us on 98251 06264. Thank you everybody. Thank you for listening us.